Hello! Today we're going to learn about composite figures. So a composite figure is just a shape that is made up of multiple shapes. Okay? And they're kind of like pushed together to make one shape. And you'll see some examples like this is a composite figure. This is a composite figure. It's just two or more shapes that are pushed together to make one shape. Right? To find the area of a composite figure, first you want to break apart the shape into areas that you can find. So you want to separate it into shapes that you know. Right? It could be squares, rectangles, parallelograms, triangles, trapezoids, circles, semicircles, any of that stuff. Anything that we have an area formula for, you want to separate it into those. All right? Then you want to find the area of those shapes, and then find the sum of those shapes. So you find the area of each shape, and then you add them all together, and that gives you the composite figure's total area. All right, for perimeter, you want to find the perimeter of this shape by finding the measure of each side of the figure, and then add up all the sides of the figure, and that will give you the perimeter. Okay, so we have this shape here. It kind of looks like an upside down house to me. Maybe like a home plate, baseball, something like that, right? I want to separate this into shapes that I know, right? So I see that if this dotted line here already kind of separates it. I see I have a rectangle up here and a triangle down here, right? So I know I have a rectangle plus a triangle. So rectangle, and then I'm going to add the area of that to the area of the triangle, right? Okay, so area of a rectangle is length times width. Area of a triangle is 1/2 the base of the triangle times the height of the triangle. Okay, so rectangle, length times width, that would be 12 times 9, right? That's my length and that's my width. 12 times 9. It doesn't matter which one you label length and which one you label width, right? Because you're multiplying, so it doesn't matter which order you multiply in. 12 times 9 is 108. So I have 108 for my rectangle. That's the area of my rectangle. But I'm not done yet because I have to find the area of this triangle. So the area of this triangle, I see the base of the triangle is the bottom of the triangle, not the point of the triangle, is right here. And that is 12 because I know that rectangles, opposite sides are equal, right? So I'm going to do 1/2 times 12. And then the height of my triangle, you can see is this dotted line here going up like this. And it's saying that is 7. So my height is 7. And then I would just multiply all these three numbers. 1/2 times 12 is 6. 6 times 7 is 42. So now that I found the area of the rectangle and I found the area of the triangle, now I want to add them together. So if I add 108 plus 42, that's going to give me 150. So 150, and then this is measured in feet, so it'd be feet. And then area is always squared. If you're curious to why it's squared, this is why it is squared, okay? So let's just take the rectangle example. It's really 12 feet times 9 feet, right? So 12 times 9 gives you 108, right? What is feet times feet? Well, feet times feet is feet squared, because anything times itself is squared. So that's why your units are always squared for area. Okay, so now let's do perimeter. So perimeter of this shape, I have to know all the sides of my shape, right? So I see that this side is 9. I see that this side over here is 12. This side it didn't give me, but I know rectangles opposite sides are equal, right? So if this side's 9, I know this side's got to be 9, right? Down here, I have to know this length, and I have to know this length. They didn't give those to me. So how could I figure that out? Well, there's a big hint here. I see there's a right angle right here. So this makes two separate right triangles. So knowing that right triangles, I can use the formula a squared plus b squared equals c squared to find my missing side of a right triangle. It's going back to Pythagorean theorem, right? So here's my right angle. I know the side opposite of my right angle is c. So I'm looking for c here, right? So that means that I know that one side is going to be 7, because that's the height. That's this dotted line here, right? I'm going to plug that in for, let's plug that in for b. Sure, we'll make that 7 squared, okay? We'll make that one 7 squared. I don't know what c squared is. That's what I'm solving for. All right, now a, I see that this triangle is cut in half. This dotted line is cutting this triangle in half, right? So this whole side here is 12, right? That whole side here is 12. I'm not looking for the whole side. I'm looking for half of it. I'm looking from this dotted line to here to complete this right triangle over here. So half of 12 will give me 6. So this side here is 6. So a squared would be 6 squared. Okay, so now I solved my Pythagorean theorem, right? So 6 squared is 36. 7 squared is 49. I don't know what c squared is, so that just stays c squared. All right, then I would add these two together. 36 plus 49 equals 85. So it'd be 85 equals c squared. And then remember, I want to get rid of that squared, and I want to get c by itself, right? So the opposite of squaring a number is taking the square root, and that's what's going to get rid of that squared sign there and leave me with just c. All right, so then I got to do the same thing to the other side. I got to take the square root of 85. And the square root of 85 is 9.219544457. So I'm just going to round it to 9.2. 9.2. So now I know that this side here is 9.2. And I know that this side over here, it's the same triangle, right? I still have 7 here, and this side would still be 6. So I know this side is also 9.2. So now to find my perimeter, I would just add all those sides together. So I would do 9 plus 12 plus 9 plus 9.2 plus 9.2. And what do we get? Let's see here. 9 plus 12 plus 9 plus 9.2 plus 9.2 is 48.4. So 48.4. And for perimeter, it's just the units. It's not squared. You're not multiplying the units. You're adding them together, so it just stays feet. All right, and that's your answer, 48.4 feet. All right, so sometimes when you're finding perimeter, you're going to have to use things that we learned in the past, like Pythagorean theorem, to find a missing side. All right, this shape here, this kind of looks like the track going around a football field, right? What shapes do we see? Well, I see a rectangle right here in the middle, and I see 2 semicircles, or 2 half circles, right? So I see a semicircle I'm going to have to find, and I'm going to have to find the area of the rectangle, and then I'm going to have to find the area of the other semicircle. Once I find the area of those, then I can add them together and find the area of the whole shape, right? So rectangle is the easiest. Let's do that first. Length times width. All right, I see that my length and width is 150, right? So it'd be 100 times 50 times 50. 100 times 50, it would just be 50, and then you add 2 zeros to it, right, for the 100. So it's 5,000. Area of a circle is pi times the radius squared, right? But I don't want to know a circle. I want to know a half circle or a semicircle, because it's not a full circle here. It's a half a circle, right? So I want to find the area of a circle, and then I want to divide it by 2 to cut it in half, right? So let's do that. So pi, I'm going to use 3.14 for pi, just so we don't get like a crazy decimal. So 3.14 for pi. Radius is halfway through the shape, right? So this whole shape, the whole diameter is 50. I'm looking for halfway through that. Let's change colors here so I can show it. All right, so I'm looking for half of this shape, half of that number. So that would be 25. 25 and then squared. All right, so order of operations is I have to do the exponent first. So 25 squared is 625. And then I would multiply that to 3.14. And that gives me 1,962 and 5/10, or 0.5. Okay, so I found the area of the rectangle. That's the 5,000. I found the area of one semicircle. That's 1,962 and 5/10, or 1,962.5, right? And I have another semicircle. I don't have to find this other semicircle, though, because this semicircle over here is the same shape as this one. It has the same radius, right? So I know that this one is also 1,962.5. I don't have to do all that work again, right? Now I just want to add these 3 numbers together. I add those 3 numbers together, that's going to give me my final area. So 1962.5 plus 196.25 is 3925, and then I add 5,000, and that will give me an area of 8,925. And this is measured in yards, and area is always squared. All right, so now I got to find the perimeter of this shape. So the perimeter of this shape is going around the whole shape, right? So I see that this side is 100, and I would also know that this side's 100 because opposite sides of rectangles are equal to each other, right? What I don't know is I don't know this part over here or the curve over here, right? So that for that, I have to find the circumference of those semicircles, right? So the circumference of a semicircle or a circle is pi times d. That's the circumference of a circle. Pi times the diameter. But I'm looking for a semicircle because I'm looking for this curve and this curve, right? So I'm looking for a semicircle or a half circle, so I'm going to find that and then divide it by 2. All right, so pi, once again, we'll use 3.14 for pi. And then for diameter, the diameter is all the way through the circle. So that's the whole thing, which is 50. And I can just multiply those together. 3.14 times 50 gives me 157. 157. And then I could divide that by 2 to get my semicircle. And 157 divided by 2 is 78.5. That's an ugly looking 8, but that's an 8. All right, so this curve over here is 78.5. And this is the same shape over here, so I know this curve over here is also 78.5. So now I can add all those together and get my perimeter. So it'd be 78.5 plus 100 plus 78.5 plus 100. If I add all those together, I get 357. So my perimeter would equal 357, and this is being measured in yards. And that would be my perimeter. Okay? So key takeaway, for area, you want to break your shape up into the shapes you know. Shapes you have formulas for to be able to find the area. And then you find the area of each shape, add them together, and that gives you your area. For perimeter, you have to find the sides of all, the measures of all the sides, and then you add them all up, and that gives you your perimeter. All right, if you ever have any questions, please ask a teacher, and I'll catch you next time. Bye.